guys, let's finish up question number 2 on the constructed response part of this. We have a voyeur here in the room. But here we have 9th grade students. This constructed response question wants you to make a scatter plot based on this data of students, their weight and their backpack weight. I guess the school weighed them, which seems stupid. I wouldn't let anybody weigh me. But it's the question. Question A says, label the axis and scale and title the graph. Make sure you read all directions on the test. You don't want to miss something because you didn't read that direction on the test. So we have, if you can see, I made student weight the explanatory variable. I titled it, just like Mr. Kearns taught us all, the relationship between student weight and backpack weight. So you get both variables there. The response weight was backpack weight. I counted by 20s for student weight so I could get up to 187. I guess plotter weighs 187. And I counted by 5s on the backpack weight. You guys should be able to do this fairly easily. Here's my dots for my scatter plot. If you want to pause this while you do that, I'm just going to quickly bust through the rest of this question and teach you how to use the calculator to find correlation. So if you need to pause this and make your dot plot, your scatter plot, do that now. Otherwise, we're going to continue on. I wanted to show you, if you take this data and enter it, I've already entered it into the calculator, okay, in list 2 and 3. So I have here, and actually I'm missing plotter because you have to take him out at some point during the question, so I did that already. So let me enter him in at 187. At his weight, and his backpack weight is 30. And we can kind of see from where he ends up on the scatter plot that he's a little bit of an outlier here, because it looks like these dots, if you kind of drew a line, they would continue up like, this might not be the best line, continue up like this. So for his weight, plotter's backpack is kind of light, and because outliers really skew data for correlation, that's going to really skew our data a little bit. But there it is, entered into list 2 and list 3 for me. We're going to go into stat, calc. We're going to go down to linear regression. Now remember, this is where it's important. Before this point, you have had to turn the diagnostics on by doing catalog, which is second 0, arrowing down to diagnostics, turning it on. I did that in a previous video. Okay, and I've already done this. I hope it's still there. So I enter. I put my stuff into L2 and L3. Some of you have a calculator that at this point is going to ask you this question here. Not that one. Here. And it's going to bring it up like this, in which case you're going to have to type in list 2 and list 3 by doing second 1, comma, or 2, I'm sorry, second 2, comma, second 3, okay? But my calculator here is set up that it's in there this way, all right? And I'm going to enter, calculate. Cool. And this is going to give us all of the information very quickly that we're going to need for the rest of this problem, okay? And I'm going to have this information. I'm going to set it aside, okay? So first question after the graph is, using your calculator, calculate the correlation between body weight and backpack weight. Boom. It's right there. It's R. It's 0.79. I put that down here, okay? Next one, C says, suppose that Plotter decided not to go on the trip. We already know he's a little bit of an outlier, so how is that going to change the data? It says, how will the correlation change? Well, the correlation is going to become tighter around that line because he's not going to be dragging it down, okay? So that's going to make the number of correlation go up. So I said it will go up because he's a bit of an outlier. Calculate the new correlation. So what you're going to want to do to calculate the new correlation is, hold on, I just want to make sure this is in here. Okay. Calculate the new correlation. You need to go back in where I was, okay, and edit this to take him out. So I'm going to delete him here, then go back to stat, calc, 4, do it again. My new correlation is, 0.94. I must have put an r squared last time. It's a good thing I caught that. 0.94. There, okay. So, r squared was the 0.89, which I had there. 0.94 is the other one, is the new correlation. So it made the correlation higher by 0.79 and 9, 10, 11, 12, 13, 15. Okay, 0.15. Good. Explain this effect. I said the correlation became higher because Plotter's weight was high in comparison to his backpack weight. And like we know, outliers really affect the correlation. Okay. Now, the equation of regression line, I think this one was based on the wrong information that I put there. So let me erase this. Okay. But it should still be, this question is worded a little bit weird. I don't know if it wants me to use Plotter's data or not. I'm going to go ahead, go back and put it in. So stat, edit, 187.30. Okay. Recalculate it again. Okay, and it's going to give me everything I need. It's going to give me the slope, and it's going to give me the y-intercept. So my slope is 0.09, because that's the A, or whatever one is next to the X. X plus, and my y-intercept here, which is represented by B, 16.26. What do these mean? I wrote it down for what I had written down already. So the slope means that for every pound a student weighs, their backpack will weigh 0.09, because that matches my slope number, 0.09 of a pound more. The y-intercept means that a person who weighs nothing will still have a backpack that weighs 16.26 pounds. So even though that doesn't make much sense, that's what it means in this real life situation. Use the least square regression line to predict the backpack weight for a 112-pound person. Okay, well, if that's the case, I'm going to take this off because I calculated it wrong again because my equation was off. So let's redo it. That'll give you a chance to realize how I did it. Y equals 0.09 times 112 plus 16.26. And I'm just going to solve that here. 0.09 times 112 plus 16.26. Okay. 26.34, so it doesn't affect it too much, but the answer is 26.34 pounds. All right, so that's the last answer for question number 2. I hope you have had a good time studying with